Hi guys, welcome in this lecture. In this lecture we study about interference of white light or visible light. White light or visible light are same. In this chapter, this is the last topic of interference. Visible light or white light is made up by different colors light, and as 7 colors VIB GYOR, विबग्योर जिसे बोलते हैं ये. White light is made up by different colors light, and the wavelength range of visible light or white light is from 3500 angstrom to 7500 angstrom. Mostly it is used as 4000 to 8000 angstrom also, but now we use only 3500 angstrom to 7500 angstrom. And this is the wavelength range of white light or visible light. Due to different wavelengths, fringe width also be different due to different wavelength. Okay, because fringe width is depend on wavelength, and wavelength is different, so width of fringe also different. Okay, and the central fringe at the center, fringe at the center is called central fringe. Central fringe will be white due to white light interference, because at center there are no path difference for any color light. There are no path difference for any color light. So due to there are no path difference, so all colors are mixed in same quantity, so there will be white or visible fringe at the center. Okay, after that, as I understand you as a diagram, as this is center. At center make a white fringe. After then both sides will be red fringe or fringe of red color in both side of center, and after then red to violet color. So after central fringe, in both side red to violet fringe are received. After central fringe, in both side of central fringe red to violet, इधर भी red to violet, इस side में भी red to violet fringe are received. And after then, after red to violet fringe, there are no clear fringe are received. Fringe are mixed up, not clear. Okay, this is the interference of visible light or white light. Okay, after then new phenomena of light is diffraction of light. Diffraction of light. Okay, diffraction of light. What is the diffraction of light? In this phenomena, light incident on obstacle or aperture. Obstacle क्या है? एक अवरोध है. In the path of light, कोई अवरोध आता है, उसे अपन बोलते हैं obstacle. ठीक है. एंड यदि अवरोध है, उसके बीच में कोई स्लिट है जिससे प्रकाश लाइट है वो आगे जा सकती है, तो उसे अपन बोलते हैं अपार्चर. मीन्स इफ देयर लाइट इज इंसिडेंट ऑन एट obstacle or aperture. If light is incident on obstacle or aperture. Then light is bent around the corners of obstacle or aperture and move towards geometrical shadow region. Move towards geometrical shadow region मीन्स यदि लाइट इंसिडेंट हो रही है, बीच में अवरोध आ गया, तो अवरोध के पीछे लाइट होती है. देखो ऐसे किनारों पर मुड़कर ऐसे जो शेडो रीजन होता है इसका, उस रीजन में भी लाइट स्प्रेड होती है, फैलती है. दिस फिनोमिना इज नोन एज डिफ्रैक्शन ऑफ लाइट. ओके. एंड कंडीशन फॉर डिफ्रैक्शन. What is condition for diffraction? That the size of obstacle or aperture will be the range of wavelength of incident light. ओके. इंसिडेंट लाइट जो है उसके वेवलेंथ की रेंज की साइज होनी चाहिए किसकी? ऑब्स्टेकल और अपर्चर. ओके. दिस इज रिटन ऑन स्क्रीन. Interference of white light and after then diffraction of light and condition for diffraction. You can take screenshot and prepare your notes. After it we study about normally a derivation for diffraction. That is, for this derivation we take a formula that derived in next class of diffraction. We use directly this formula in diffraction. Path difference delta will equals to a sin theta. This equation also be derived in next class. Okay. Delta is equals to a sin theta. We apply first condition for central maxima. At center, in diffraction at center, intensity will be very high. That is called central maxima. For central maxima, path difference delta is equals to 0. Then by this equation 0 is equals to a sin theta and sin theta is equals to 0 a upon में आएगा 0 upon a, means sin theta is equals to 0. Because sin theta approximate equals to theta, so theta will equals to 0 for central maxima. Okay. After this we take for minima. Delta is equals to n lambda. Okay. Minima is that point at where intensity is minimum in diffraction. That point is called minima. Okay. At minima we take path difference as constructive interference. कंस्ट्रक्टिव इंटरफेरेंस में भी हमने ये पाथ डिफरेंस लिया था, यही आएगा किसमें? मिनिमा में. डिफ्रैक्शन के मिनिमा में वही पाथ डिफरेंस आएगा जो कंस्ट्रक्टिव इंटरफेरेंस में आता है. ओके. तो ये डेल्टा एन लेमडा इसमें पुटअप करेंगे, तो एन लेमडा, देन एन लेमडा इज इक्वल्स टू ए साइन थीटा एंड साइन थीटा अपन कैलकुलेट करेंगे तो आएगा एन लेमडा अपॉन ए. For small angle sin theta approximate equals to theta, then theta is equals to n lambda upon a. Okay. After then, for maxima, delta is equals to 2n plus 1 by 2 lambda. For maxima, this is the central maxima, and at center intensity of this maxima will very high, and intensity of this maxima is high but not very high. Okay, for this maxima, path difference is equals to 2n plus 1 by 2 lambda. This is path difference for destructive interference. We use this path difference in destructive interference. Okay, we put the value of delta in this above equation, then 2n, then 2n plus 1 by 2 lambda is equals to a sin theta, then sin theta is equals to 2n plus 1 by 2 lambda upon a. For short angle, sin theta approximate equals to theta, then theta is equals to 2n plus 1 by 2 lambda upon a. This is the angle for maxima, this is the angle for minima, this is the angle for central maxima. Okay, this is the derivation for diffraction. After then, we show the intensity pattern, intensity distribution curve in diffraction. Okay, इंटेंसिटी डिस्ट्रीब्यूशन कर्व, इंटेंसिटी डिस्ट्रीब्यूशन कर्व क्या होगा, देखो इस प्रकार से होगा, इंटेंसिटी इन दिस साइड एंड इन दिस साइड फेज डिफरेंस, एट सेंटर मैक्सिमा, center maxima, after then minima and maxima, and intensity will decrease continuously, intensity will decrease continuously. Okay, as this is 0, pi, 2 pi, 3 pi, pi, 2 pi, 3 pi, this. Okay, this is the intensity distribution curve in diffraction. This is not equal to each other. Central intensity is maximum, after then intensity will decrease slowly. Okay, this is the diffraction intensity distribution curve. Now you can take a screenshot and prepare your notes. Okay, thank you.